Welcome to our presentation. My name is Mark Sanders. I'm Chief Technology Officer of Clement Clarke International. My co-authors are Alex Thomason, Clement Clarke's Design Engineer, and Dr. Kong Tran, Senior Research Scientist at I2C Pharma. Our presentation describes a new PMDI actuator that we hope will help patients with their inhaler technique. The actuator includes a new additional component that delivers an acoustic signal that will guide patients' technique and also log the details of the inhalation maneuver. The development program for the new actuator, which is called the Intone, had the following objectives. Firstly, to create a new actuator for patients that is essentially familiar to their PMDI inhaler device. Secondly, to guide patients to better technique. I'm sure we are all aware of the high level of patient errors using PMDIs. Thirdly, to provide a sound that would prompt a coordinated action and the correct duration of inhalation. Fourthly, to produce the same APSD performance as a standard actuator and also to be compatible with the new HFC 152A propellant. Additionally, to use acoustics rather than electronics in order to keep the cost low, and to be able to provide real-time feedback, because at the moment, Bluetooth devices can only do this retrospectively. Seventh, to be suitable for large-scale manufacture in the same way as a standard actuator. And lastly, to ensure that the acoustic signal is suitable for smartphone detection and will provide real-time patient guidance and feedback on technique, log activity of patient use while the app is working in the background, and differentiate between preventer and reliever use, which is an indicator of asthma control. The new actuator provides positive reinforcement to inhaler technique by creating a sound as inhalation air is drawn through the acoustic feature. The sound is a cue, indicating that the canister can be pressed and then that the sound should be maintained for about 5 seconds, which all ties in with the PMDI instructions. If a patient inhales too fast, that is above 45 litres per minute, then there is no positive reinforcement sound. The question we sought to answer with the work presented here is whether the location of the acoustic feature, which is near to the stem block, has an effect on aerosol particle size delivery. We've conducted 2 experiments. The first experiment used the standard Ventilink PMDI, and the second used a trial salbutamol HFC 152A formulation using the Zephex 152A from Cora. In each experiment, these PMDIs were compared with the new Intone actuator and matching formulations. The critical components of the Intone were moulded and the actuator body was 3D printed. Stem block orifice sizes were matched, and we also investigated the effect of changing orifice size. Here on the left, you can see the modular assembly of the experimental version of the actuator, with the Intone acoustic feature shown in yellow. The Intone is designed to sound as inspiratory flow reaches 20 litres per minute and to stop at 45 litres per minute, thus identifying a correct range of inhalation rates to the patient. When the patient hears the sound, they know to actuate the inhaler and then to keep the sound going for about 5 seconds. You can also see the stem block visible through the blue sleeve, but please understand that the final product would not be modular. It would be either a single, as shown on the right, or 2-piece moulding, as may be required to accommodate any counter system. So, is the Ventilink comparison, and you can see that the Intone actuator, shown in orange on the graphic, is able to match closely the delivery from the standard Ventilink device, shown in blue. Here you see the HFC 152A comparison. We've used 3 different stem block orifice sizes, and you can see that the 0.3mm, again in orange, is a good match to the trial formulation. Although I would note that the doses are above the standard range for salbutamol. You can also see the impact of increasing the orifice size, which with this formulation decreases the fine particle dose. So, we have been able to match the APSD from both comparators and been able to gain some understanding of the impact of orifice size, which will be useful if we were trying to tune performance to match a requirement. We conclude, therefore, that these early data support the intended location of the acoustic feature proximal to the stem block without detriment to performance. Together with other data already published on improved technique from guided delivery, which is derived from our retrofit clip zone program, this represents a possible way forward for a low-cost signaling inhaler that can be manufactured at scale and will be applicable to new HFC 152A formulations, providing patients with a device that helps them to use it properly. So I'd just like to extend our thanks to Cura for the trial formulation and to our collaborators at I2C Pharma for their lab work. Thank you.